Okay, we're going to get started. This room is sponsored by Rubicon. The Rubicon project has engineered the Advertising Automation Cloud, one of the largest real-time cloud and big data computing systems. The company's mission is to automate the buying and selling of advertising by offering innovative products to connect buyers and sellers globally. For more information, visit rubiconproject.com. We also ask if you could take a moment to visit the speaker session feedback form. It's on the card that came with your badge. We appreciate the feedback. Okay, our talk today is on distributed version control and Mercurial. Lan Deng is our speaker. She's going to be discussing different version control systems from the ground up and doing a comparison between Git and Mercurial. So without further ado, I give you Lan.
My fault. I thought I could speak loud enough, but I guess I should go through the sound system. So, this talk is on distributed version control systems, and the focus is on Mercurial. And the reason the talk exists at all is because a couple of years ago, I was preparing for a new task at work. I was taking on the role of being the Mercurial administrator for my team, partly because I thought, Mercurial, Git users are always bitching about that, so I guess they're kind of similar, right? And I'm familiar with Git. How hard could it be? So I forgot the administrator part and the fact that, you know, if you're a user, you can get by knowing a few commands, and it's fine. You can get through your day. If you need anything else, you can look it up. But when you're the administrator, you kind of have to act like the expert, even if you're not quite sure what you're doing, and you have to give good advice, because unfortunately they're putting the repositories in your hand, and if you mess that up, I don't even want to know. So I quickly realized that it's not good enough to know the commands. I really had to understand how distributed version control works underneath the covers, so that when I'm looking at solutions to possible problems, I'm making the best educated choice in my advice to my users and in what I do. So I have a little guilty admission to make. I'm reusing a talk that I gave at my lug over a year ago. But the reason I'm doing this is because I actually put a lot of work into the slides. They caught me at a time when I was just doing a lot of research, and I had all this information fresh in my head. And what I immediately did is I made a whole bunch of slides, about 69 in total, and it kind of encapsulated a lot of what I had taken away from my research. And these slides are not slides that I really mean to present all of. They're really meant for later on, if you're interested, you can revisit them. They're kind of like a resource for you. And I have a very nice set of annotated references if you want to go back to the original source material. So some of the material is a little old, but I like to think that there's a lot of quality in there. Also, since I was giving the talk at the lug, I knew that we have a problem sometimes when you give talks to a technical audience that some of the audience is really into it and they want to know everything, and others are not that familiar. And so you really want to have something for everyone, and that's what I try to do. I try to go over the basics of version control systems. I try to go over the basics of Mercurial. I hope that all of you will get a little something out of this. And remember, 69 slides, you don't have to read them all in one go. I'm not going to read them all in one go. So this is my roadmap. We'll start out talking a little bit about version control systems. Apparently there's a definition for them, and so that will give you a better appreciation of what version control systems give you. When I talk about DVCS concepts, distributed version controls, they have a kind of language to them. Like when you talk about change sets, repositories, I want to make sure that you understand what I mean when I start throwing those terms around. For Mercurial basics, I'm really going to skim over that, because if you're that into Mercurial, you're going to go through it step by step, and it's better as a hands-on experience. The thing that I always like to talk about is Git versus Mercurial, and this is not to say that one is better than the other. It's more like I feel like the Git tool and the Mercurial tool were kind of developed with different philosophies in mind. And that's why you have some people who really like the Git way of doing it, and you have people who like the Mercurial way of doing it. But since the work that I do involves Mercurial, I will be doing a lot of talking about things that I've had to deal with in Mercurial, things that I've discovered about how Mercurial works underneath the hood. And I hope that whether or not you use Mercurial, it does inspire you to look deeper into distributed version control systems and the building blocks, and really kind of like educate yourself more about what's going on underneath the covers. I have a bunch of case studies. I'm also not going to go through them, but if you ever have issues with your repositories, I have some recipes that may or may not work for you. And I have a lot of really nice references if you want to learn more about Mercurial, or if you want to know like how Mercurial and Git are different. There's a really nice set of videos that requires that you pay attention for like several hours, but you can break it up. But it's a really good way of learning how version control systems work, because if you learn things in different ways, it'll gel better. And those videos definitely help when they have like the graphics and they have the animation. So I always like to put in a disclaimer. I'm not a version control expert. A lot of this I learned on the job, and I learn what I need to learn to do things. And I always feel slightly guilty that for my users, I only ever support them on Linux or Unix. I've never had a reason to run Windows. I don't run Eclipse. I don't run Tortoise HD, so I can never help them off the top of my head. So that's apologies to all you Eclipse users that I failed to help. So Eric Raymond gives this definition of version control systems as a tool that gives you the capabilities of reversibility, concurrency, and annotation. And if you're asking what that means, so did I. So when I explain version control to people and I try to convince them that it's a good thing to do, I tell them first off that it gives them the power of time travel. So if you've ever done something that you kind of regretted and you wish that you could go back to time and get a do-over, version control systems will give you that power with your files. They give you the ability to make checkpoints, like save points in a game. And then if you take a step that kind of led you in the wrong direction, you can kind of back up. You can back up one step, you can back up multiple steps. If it turns out that there is this file that was perfect like 3 steps ago and you want to retrieve it, you can go back and retrieve it. So version control systems are like your safety net. Version control systems are also really good, and so that's what Eric Raymond meant by reversibility, the ability to kind of get the do-over. Version control systems are also really good for collaboration. You know that we don't work in a vacuum. We have to work with other people. We're often working with the same set of files. And so we have this issue of concurrency. How can you work on the same set of files and keep them in sync and not clobber each other? So I have the bad news that version control systems won't totally help you with that, because I've seen enough times when people clobber other people's work that I know that you're going to need an administrator or some kind of policy person to come in place and teach people the proper way to merge. But for other things, like if somebody's modifying a file over here and somebody's modifying a file in a completely unrelated area, version control systems are pretty good at merging them together. And so they make it easier to collaborate with other people because you eventually end up on the same page. You end up with the same set of files, the same set of source code, and you can move on from there. So the thing that I realized when I was looking at this definition is that Google Docs kind of fulfills the first 2 criteria. It has a revision history and it lets you get back to any point in time. And the beauty of Google Docs is the collaboration aspect. You can edit a file, someone else could edit a file at the same time. So that handles concurrency. But what it doesn't handle, and it's the same thing with wikis, what it doesn't handle is what is called annotation. The ability to kind of label like your little save points. So when you encounter a problem, usually you don't know immediately like how far you have to go back. You just know that a problem happened between here and Tuesday. And if you had a whole bunch of change sets between then, how are you going to back up far enough to the point where your last known good state? Where if you were able to annotate it, if you were able to annotate your change sets, and you were able to explicitly say what you did every time you did a commit, then you could kind of guess from the commit log messages, like where you should go back, where the problem started. And so the best thing about version control systems, in my opinion, is the ability to track changes, to more easily be able to track your way back to a good state. So this is a little history of version control according to Eric Raymond and Eric Sink. We have 3 generations of version control systems, and I mean, it kind of makes sense. You start out like not having any networks, and you're dealing with one file at a time. And the way that you have multiple people working on it is that someone kind of like gets a lock on the file, they get to make the modification, and then when they're ready to let go, and someone else gets to make the modification. Then when we started having more networks, then you had to deal with the fact that there are multiple people on different machines wanting to make changes. And so they have a centralized server that kind of mediates it. And so everyone talks to the centralized server and gets their changes in. And what's important in this model is that for concurrency, when multiple people are working together, the way that you have to commit your change to a central repository is first you have to deal with the merging. You have to get whatever changes were new in the central repository, deal with it in your area before you can push these changes back to the central repository. I feel like I don't really like that model, and that's the reason why I've never really liked Subversion, because I'm not able to freely save my state. I kind of like have to like be very judicious when I commit back to the central repository. And so I really gravitated towards distributed version control systems. And this is where everybody kind of like has their own copy of the repository. They can make the saves anytime they want, and eventually they will synchronize with another repository. They will push their changes to another one. And so that gives you a lot more freedom to save all the time, constantly. And you're less likely to lose your work that way as long as you commit it to a repository. And so you can see that what we'll be talking about today will be mainly Git and Mercurial. I only recently learned about Bazaar, not this version of Bazaar, but BZR. And I learned that it was another distributed version control system that had Canonical behind it, and they had a lot of major projects using it. But it seems to be dying down. It seems to be like it's not being supported as much, and so people don't like using a tool that is not being actively maintained, because if you run into a serious bug, you really want to make sure that someone's going to take care of it. And so that's why these days, when it comes to distributed version control systems, we'll be talking mainly about Git and Mercurial. So I'm only showing you this diagram because, first of all, I want to highlight that the Getting Git screencast is an awesome video. It's very dense. It's mostly images. You will learn a lot about source control in it. But what I like about this particular image is it shows you one of the differences between Mercurial and Git. And you can see that the way that they store the different versions of the files is different. A delta storage means that the way they store the different versions of the file is by storing the delta, the difference between like one version and the next. And it's kind of like on a file basis. And so Mercurial and Subversion both kind of use the same delta storage technique. In comparison, like Git, it uses a DAG storage, which I can't tell you much about, but it's the concept that it takes a snapshot. So instead of like just storing the delta between one version and the next, it's actually storing a snapshot at that point in time. And the only reason that this doesn't balloon up and become like this humongous repository is that they use little tricks. Like if they have an object and they have multiple copies of an object, all the multiple copies are actually only linking to one object. And in this way, they can kind of save on space. But the consequence of these different storage models is that when you're using like Mercurial and Subversion, they're a lot more tolerant if you stick binary files in your repository. If you do it in Git, you will notice a distinct hit on performance, because Git was not really meant to do that. And especially because of the way that it stores its data, it does cause the repository to balloon up. There is this neat video. It's 90 seconds long. It's got some nice music. So I'm going to leave it up to you guys whether I play it or not. Yeah. You want it? Let's see if I can find it. Come on, YouTube. So this is just to convince you. Time to move to distributed version control. So does that look good to you? So for the people in the audience who don't do like software development and don't really see a reason for version control or distributed version control, it made me want to use version control. Like I told you that I didn't really like Subversion. It seemed like a lot of work when all I wanted to do was to maybe like version control a few documents. It just seemed like a lot of work. But if I use something like Git or Mercurial, as long as I have the software installed, it's as easy as just making a directory, doing like a get init or a hg init, and suddenly I have a repository and I can start committing changes to it. And so I started using it for scripts. I use it for configuration files. I use it for my notes because I write my notes as text files. People start using it for other things, like they'll use it to synchronize files. Like you can use it to deploy websites, for example. And if you are a GitHub user, you'll know that everything that you get in GitHub, they will tell you it's a repo, it's a Git repo. Everything they have is pretty much a Git repo. One of the most powerful things about distributed version control is because you're no longer tied to a central server, you now have the ability to work offline. You don't need to care if you can't VPN to work. You don't need to care if you're out in the desert, you're on an airplane, you're in a place which has no cell signal. You can still get a little work done. And that's really like helpful because you're not like trapped by circumstances. You can work whenever you feel like it. So I don't really want to get too much into the basic concepts. As long as you understand what the concept of a repository is, the repository is basically the structure that has all the different versions of the files, that it knows everything about the state of your project, for example. It has like the entire history of it, it has the metadata, it has all the change logs. It's all stored in the repository. And in distributed version control systems, it's usually stored with your working directories. And the reason why I'm emphasizing this is I have seen people get in trouble due to this, because the repository is often a hidden directory in your working directory. If you were using Git, it's a .git file, which you wouldn't see unless you are always displaying your hidden files. And Mercurial is a .hg directory. And the reason why this is dangerous is if you tend to be careless in your working directory, if you think, oh, whatever I do, it doesn't matter because it's all kept in the repo, that's true as long as you aren't doing like crazy things like having a script that kind of goes through and does a search replace in all the files in your directory, or that does a move based on whether this file matches a certain criteria, or does an rm-rf on certain files. Because when you do that, there's always a chance that you're going into that hidden directory that has all your important repository information in it, and you're somehow corrupting it. So this is something that when you're using distributed version control systems, you should always try to make sure that when you make changes, when you work in your space, you are shipping it out somewhere. You are synchronizing with somewhere upstream, so that if you do something that hurts the file system where you're working, at least you'll know that you wouldn't have lost all of your work. So that's the one thing that I really want all of you to come away with, is to be respectful of what's in your repository and always make sure that you push the changes upstream. And let me see. Since a lot of you already kind of know about Git and version control, I'm going to skip over some stuff that you could probably read later if you're interested. And I'll just get straight to the summary. So in distributed version control systems, as you know, everyone has a copy of the repository. And that's why we call it cloning. We don't call it checking out. It's not like we're borrowing a library book. We have our own copy of the repository. And the way that you work in distributed version control is that you have your own copy of the repository. We'll call it the local repository. It's the one that's closest to you. You make any changes you need to, and when you want to synchronize upstream, you push those changes up. So with the upstream or remote repositories, the general rule of thumb is that you try to pull in the new changes, you deal with the merges, and then you push it back out. That's how you do distributed version control. So if you were to get into Mercurial, I have some tips about how to configure your system to start out with so that you can kind of start using Mercurial right away instead of getting stuck by these cryptic error messages. So the very first thing that you should always do is you should tell Mercurial what your username is. Because the only way that Mercurial or any version control system can make a commit message and credit you as an author is if you tell it who you are. And so usually you just put this in some kind of configuration file and you forget about it. And this is how you do it in Mercurial. The other useful thing, and I would recommend this whether you're using Mercurial or you use Git, is that you use some kind of extension that would change your shell prompt to give you an idea of the status of your directory. Let me see. So this is a Mercurial repository that I just set up right now. And you can see that there's some extra stuff in my prompt, and I'll show you how you can tell. This is what my prompt looks like when I'm not in a Mercurial repository. It's a pretty plain prompt. If you compare it with the one above, which if you look at the projector, I'm hoping you can see, I broke my rule about changing the color of my terminal when I do presentations. Sorry about that. So what you can do with the prompt extension is that you can encode extra information about your repository state in the prompt so that you aren't constantly asking the repository, hey, tell me what my state is, tell me which branch I'm on, tell me where I am in my repository. By encoding the information in the prompt, you can look at the prompt and know right away, hey, I didn't commit something. So what this prompt is telling me is that I'm on the test 1 branch. And it's telling me that I've committed all the changes that I want to commit. How can I tell? Well, I suddenly added a file, and now it gives me a question mark. So I know that there's something that is new in this that I haven't saved. And when I do this, I can see that there's a file in there that is being untracked because I kind of know that question mark stands for untracked file. So by having these little clues, it makes it a lot easier for you to understand what's going on in your repository, to know where you are. I've mentioned before that in repositories, you kind of have the power of time travel. So one of the dangers of having the power of time travel is you kind of go back in time and then you start doing your work and you forget that you're not in the present, that you're working off of a change set that you committed 2 weeks back. If you commit to that change set, now you're suddenly forking your code. Instead of committing it to where you were and continuing to develop your code, you kind of made this little side branch off of an older piece of code. And then you're going to start wondering, all those cool changes that you had entered in the last week or so, where did they go? So having little indicators to tell you where you are in your repository is really, really helpful, and it will save you a lot of grief. And that's really what I wanted to highlight about these. The rest of these commands are pretty basic. If you knew Git, you can kind of see how they map. So I'm going to kind of move ahead. And get to my favorite bit. Let's talk about Git and Mercurial. So one of the things that I was really interested to find out was that Git and Mercurial haven't actually been around too long. And they actually started around the same time, and they started for the same reason. The Linux kernel team had been using Bitkeeper, which is a commercial distributed version control system, and they really liked it. It really suited their workflow. And due to something or another, which I won't get into because I don't know the details, they were no longer allowed to use it, and they had to find a different system. But they had grown accustomed to those features. So, of course, being developers, they did what developers do, and they rolled their own tools. And so Git was written in C and Perl. It's written by Linus Torvalds. And Mercurial was written in Python, and it's written by Matt McCall. I am not really that into like what goes on the Linux kernel scene, so that's the most I can tell you. But what I really wanted to get out of this is because Git and Mercurial kind of like were developed around the same time, and they developed around 2005. When you first develop something, it's like really rough, and there are like things that just don't work. And over time, as more and more people want to use a tool, they'll contribute towards improving it, and they'll contribute towards adding the features that they like. So there are people that like Mercurial, but they still like some Git features, so somehow they get it into Mercurial. And likewise, in Git, you may have users that really like Git, but they like some of the Mercurial features, and so then they start implementing. And in that way, Git and Mercurial start reaching a kind of feature parity. Like, if you really want a feature, it probably exists. And before I get into why that doesn't mean that they're interchangeable, I'll get into a little bit more detail about how Git and Mercurial are different. So Git was written in C and Perl, and it was aimed at being like really fast, and it was aimed at making merging really, really easy. So it's got a really good merging algorithm. You'll notice that Git kind of like merges things behind the scenes all the time and doesn't bother you. One of the most important things to Linus was that the integrity of the repository. There's like a lot of source code, a lot of history. He wanted to make sure that no matter what happens, he could guarantee that, and it's distributed. Everybody has a copy of the repository. Who has the one true repository? He doesn't care. All he cares is that he knows of the one change set that he's absolutely sure is a good one. It has a hashtag associated with it. This hashtag comes from the contents of the change set. The only way that change set is allowed to change is if the hash also changes. So as long as he knows what the hash ID is, he can be sure that this change set did not change. And because the change set also includes the ID of the parents, he can be sure that like all of the change sets that came before it did not change. And so one of the things that I saw in a talk with him that he said that was really important to him that he really liked about Git was that if he had like this 40-digit like ID, he could guarantee like the integrity of his repository, and all he has to do is find the person that has that change set, and he can recover all of his work, even if his like hard drive gets blown away and all that. The other thing about Git that people like is this idea of a clean history. There's like this tendency that this is kind of like fight in the distributed version control world between wanting to show all of your missteps and mistakes and keeping the history immutable, and wanting to give everybody a cleaned up version, wanting to do all the investigations, figure out the best way, and then package it up and say, this is the commit, it's perfect. And having this clean history where you can go from one commit to the next and each one is perfect. And so Git does give you the ability to kind of like work in your own, craft your commits, figure out the best way, and then when you push it upstream, you can kind of like say, here's the perfect thing. And I think in the Linux kernel project, they probably appreciate that because otherwise it would get a little messy. The other thing that Git gives you is super lightweight branches, and by this I mean that when you are working with Git, you can very casually make a branch anyway. You don't even care what it's named because you can rename it later. So anytime you want to experiment with something, you just make a branch, try something out. If you don't like it, you delete it. If you want to go further with it, but you wanted to have a better label, you just rename it, and you can keep going. And then you make the decision whether you will submit that branch anywhere or you throw it away. And no one outside of your repository needs to know because Git does not automatically push branches. The other thing that Git has is a staging area for commits, and this is something that a lot of people don't like, because they're like, why are you making me tell you what to commit? Why don't you just commit everything I've changed? And the staging area for commits is actually something I really like, because I like to make a lot of changes sometimes, but because I want the ability to back out of a change, I want to be able to say, okay, the changes to this file, let's make it one commit. The changes to this file, let's make another commit. And then if I ever wanted to revert out, I only have to revert out of one of the change sets, and I don't have to like deal with the mess of like undoing everything, because I was able to break up all my commits. So the thing about Git that sometimes people don't like, or sometimes people like, is that it really does expose a lot of the plumbing to you. So if you want to do something advanced, you have the power to do it. And consequently, it's not always the most user-friendly tool out there. So these are really, like, when you look at it, just remember all these things that I said when I get to Mercurial. Mercurial was written in Python. The thing that seems to be very important in the Mercurial world is they don't like it when you rewrite history. Like anything you commit, it should be there forever. They don't want you to go back and change it. And so even though there are extensions out there that will let you change the history of the repository, I always see notes in the Mercurial instructions that kind of like say, this is strongly discouraged. Mercurial, I feel, was really written with the user in mind. It was designed to be user-friendly. It was designed to be cross-platform. It was designed to be easy to extend, and it was designed to be backwards compatible. And they really tried to make it so that even if you upgraded Mercurial, you could still use it with the old repositories. And you might not think this is very significant, but you have to consider that any distributed version control system can kind of consist of two parts. You have the server and you have the client. And for the server, you may be able to control the version of the server you use, but unless you control the corporate environment and everywhere people work, you can't necessarily make sure that they're using a certain version of the client. And so you had a situation where you're using different versions of the client and they would like actually corrupt your repository. That would be a bad thing. So this is actually a feature of Mercurial that I really like, that they make this special effort, that they try to make it user-friendly, that they make it cross-platform so that you're not locked into having to use it on Linux or whatever. You can use whatever tool, whatever operating system that you want. But, you know, coming from Git, some of the things that they do are a little foreign to me, like the way that they treat branches and the way that they try to do a clean history. Like, I feel like the way that they want to do their workflow is that they'll make a separate repository and they'll treat it as a branch. They'll do all their experiments on it, and then they'll figure out the parts that they like, and they'll export it as a patch. And this patch is what they commit, and this patch is what goes upstream. And to me, it seems like a lot of work, and it's not something I'm really into. The other thing that Mercurial is a little weak on is that I think they outsource the merging. So a lot of times when you're doing things in Mercurial and you're trying to merge, you'll come up with a merge conflict, and they'll be like, okay, you handle it. I did the very basic thing that I could to do your merge, but I'm not a very complicated algorithm. I might skip through this part, but I've always been a big believer that if you really want to use a tool well, you kind of like have to know how it works. You kind of have to know the quirks, because people can only go so far to make a tool user-friendly. Sometimes if you know how it was developed or how it was designed, you could kind of get a little bit of extra performance out of it. I'm probably not going to talk much about this, but I was really excited the day that I finally understood directed acyclic graphs. And I'm going to tell you that if you ever want to understand how directed acyclic graphs are and what it means in Git and Mercurial, go see that video that I talked about, Getting Git, by Scott Chacon, because he does a really good job of illustrating it. This is something that I found out recently that that cleared up a lot of things for me about how Mercurial does its merging. And this is kind of like a simple table that kind of explains like how it can automate the merging. And it's something that I probably won't get into a lot of detail right now, but I have a couple of links there, and I have this simple table, and I would welcome you to like kind of read it in the future, and maybe it'll clarify in your mind like how the automated merging works. How does it know which part of the file is new? And I'm sorry that the font is like impossible to read on those links, but these are Stack Overflow links. And one of them goes into great detail about how merging algorithms work. So when I started working with Mercurial repositories, there was this thing that I started noticing in the change logs that my team kept putting in, and it was this acronym, YARM. And I stared at it a long time, and I'm like, are they doing something with Yarn? And then I realized that it actually reflected someone's frustration with how Mercurial deals with synchronizing with upstream repos. And what I found out is that when you are working on a repository together, if someone changes any file in the repository, regardless of whether it has anything to do with the file that you've changed, when you pull it in, Mercurial will ask you to merge, and then Mercurial will ask you to commit the merge. Mercurial is so conservative about the merging that it would rather you check over the results and then commit the merge. And so people who are used to using Git, where it kind of happens behind the scenes, they were very annoyed, and they're like, yeah, this is yet another random merge that Mercurial wants me to do. And so that's where it comes from. And I had to finally explain it to someone who is like confused. I'm not even touching the same files. Why am I merging? And I had to tell them, it's because you're doing a repository level merge. It's not about merging the files. It's about merging two states of the repository so that the version control system, instead of like seeing these two different like lines of development, it now becomes one line of development. And if you get into the distributed acyclic graph and those, if you learn more about directed acyclic graphs, it's like a linked list. It's like a linked list where you're always directing the link to the parent. And so you will have cases where you have like these two leaf nodes directing to the parent. You don't know which one to continue the line of development on. And so that's why they're constantly asking you to merge, so you only have like one leaf node. And I feel like I confused you by saying that, so again, go watch that video. So we finally get to my case studies. This is the one that I was telling you about earlier, about being careful about your repository and your working area. And this is how I found out about it. I found out one day that this one of my users had somehow corrupted his repository. And then he pushed his changes to the central repository and corrupted that. And the first thing I did was I tried to find a workaround so that they continue with the work. And then when I looked into it, I found out that the repository information is stored in a hidden directory. And I'm sorry that I lost some of the words in there. But basically, I was like saying if you do an RM or you do like a find command with RM and you have a pattern match, it's very likely that you will have like affected some of the files in the hidden directories. And because of that, you've corrupted your repository. And the command that you can't see at the bottom, and I will try to fix this later, is that in Mercurial, there is a command called verify. So if you run hg verify, it will kind of go through and tell you that if your repository is corrupt or not. And the earlier you know whether your repository is corrupt, the earlier you can correct it. Because what I basically say when I was solving this problem is that he basically had to put his repository to one side, he had to do a fresh clone, and then he had to patch the files and then commit that. So the earlier you know, the less change that you will have lost. Some other things that I've had to do is to reorganize the repository. This is where I'll say that one of the drawbacks to distributed version control is if everybody's keeping a copy of the repository, they have the entire history of the repository. Over time, if the repository has been around for a very, very long time, it's huge. It takes up so much space. And people who are only working on a portion of the code, they get kind of resentful. They're like, I only want to like touch this part of the code. Why do I have to check out like this giant like directory? And this is a time when you start thinking, maybe I should break it up a little bit. And so there are tools in place that you can use to kind of like extract or move around repositories. Some of these tools are used like when you want to migrate from one version control system to another, like say if you wanted to move from Subversion to Mercurial or Subversion to Git, they always have these tools in place to help you rewrite the repository. And I actually give you a lot of very detailed kind of like recipes for different ways of doing it. And I will skip ahead, especially since I somehow lost my commands on some of them. So again, I apologize for that. This is something that I really wanted to highlight, which is a case where I had to strip files from my repository. And this is because a developer had accidentally checked in some very large files into the repository, and it caused a mega slowdown to everyone. And they were complaining about it. And I was just like, look, the only thing I can do is remove it from the central repository. But the only way I can do that is if you all agree to push all your changes in, throw away your current local repositories, whatever you've been working on, and do a fresh clone. Because when you modify the central repository, you make it impossible for anybody to be able to synchronize with it again, because you're kind of rewriting history. And so when they try to synchronize with it, they're like, you don't look familiar. I don't know of any way to kind of like synchronize with you, because whatever you're doing is totally different. And so again, this is where I use the convert extension. But the thing that you should get out of this is the mitigation step, which is the reason why this file got checked in was it was accidental. In Mercurial, because it doesn't have a staging area, when you're like adding files to Mercurial, you basically can add everything in the directory, even like things like if you have build artifacts or you have those temporary files that you make, they can accidentally get checked into the repository and take up space and cause you issues. And so in this case, I kind of taught them how to use the hgignore configuration file. It's like the get ignore file. You tell it like which files, which extensions to ignore, and then now when you say, let's add all the new files, at least it will ignore those files that you don't care about, those like build artifacts that change all the time, those binary files. But something I learned during this experience, and this is a limitation of Mercurial, was that it's not just binary files that would cause a problem. It's like if you have too big of a text file, because Mercurial kind of handles files as Python strings in memory, you run into memory issues depending on which platform you're on. So these are the interesting things that you discover when you have to be an administrator. Some things that they ask me to do a lot is when they're doing development, they often make a lot of changes to a branch, and somebody will say, can you cherry pick some of them? We only want this change but not that change. And so I had to figure out different ways to tell them how to do it so that they could follow the instructions and not get into trouble. What else is there? Whoops. And that's like the end of my case studies. I might add more in the future if I come across any interesting cases. I have a list of references. When I say they're annotated, they're kind of annotated like this. So you can decide which ones to follow, which ones to pursue. I really got into this to the point where I wrote this really, really long email to my lug mailing list to tell them, you should check out these videos. Not only should you check them out, I'll highlight which minute to hone in on to learn about this. So I highly recommend that if you don't have a lot of time to watch videos, go to this reference and then go to like the timestamps that I tell you about and watch them. And again, I really love the Scott Chacon video because that's how I really started to understand how Git works and how distributed version control systems work. He was very clear. It's a screencast. He put a lot of effort into making his explanations as clear as possible. If you come from the subversion world and you suddenly find yourself needing to learn Mercurial, I would recommend this resource. Joel Spolsky is a very good writer. He's very entertaining. And I guess he converted his whole company over from subversion to Mercurial. And so he has a really clear explanation of the conceptual differences between subversion and Mercurial, and it gets you kind of like moving to start using Mercurial in your day-to-day work. For people who are kind of like, I have some Git users on my team. They don't really like Mercurial, so they find different ways of dealing with it. And sometimes I have to go over here so that I can go back and explain to them like why Mercurial is irritating them, and maybe they should try this little method and just ignore it. And so that's why I'm constantly kind of like looking at resources about the differences between Git and Mercurial, because I have to translate for them. Let's see what else. This guide to branching in Mercurial was actually really important to me because Mercurial branches annoy the bejesus out of me. So in Git, I got used to like making lightweight branches and changing the names and deleting them. In Mercurial, the branch names end up in the global namespace. So in the repository, if you decide to make a branch and you're not careful about naming the branch, you decide to name it Steve, that name is gone forever for anyone else. Because if Steve has that branch name, it exists in the repository for everyone. And if Steve decides to close his branch and someone else decides to reopen a branch named Steve, you end up with this situation where you have a discontinuous line. You have a branch called Steve that goes up to a certain point, and then suddenly it appears again from nowhere, and there is no relationship between the two. I say that as a casual example, but it irritates me when people use like really generic like branch names, and they exist in a repository, and you can no longer understand why they use that branch name and what it maps to. The other thing is that the branch names and the tag names are in the same namespace, so if they use that as a branch name, you can't use it as a tag name because it gets confusing. But reading this link really helped me understand like that in Mercurial, what's actually happening is that Mercurial branches all the time. It's just this name branch that's causing the problem, because Mercurial insists that the name of a branch is also something that is stored in the change set. And therefore, if you want to change the name of the branch, you basically have to destroy that change set and write a new one. And this is something that I actually discovered that Git does behind the scenes all the time, and I hadn't really understood it. When you do things in Git like rebase, what Git is doing behind the scenes is going back to a certain point in history, and it's rewriting all your commits, and it's throwing away the old ones. And so Mercurial doesn't like that, and that's why you notice it more when you try to do that in Mercurial. Let's see. Whoops, I just got all over the place. Whoops. So lots of other links, but you can read that on your own. Does anyone have any questions? Yes?
So what were the technology reasons for Mercurial, for you already knowing Git and then going Mercurial?
Work. The team that I support already used Mercurial. And actually, I'll be honest, they asked me if we should change version control systems, if we should change the Git. And I'll tell you, from an administrator point of view, I prefer Mercurial because there are less ways of them getting into trouble. It's much more user-friendly. Because history is immutable, I don't have to worry as much about like weird things happening behind the scenes that I have no knowledge of. The only thing I ever ask them to do is if they get in trouble with the repository, please do not blow it away. Archive it somewhere, because whether you're using Git or Mercurial, as long as you have access to the repository, and I'm always making a copy of the repository to my own area so I can do some forensics on it. As long as you have access to the repository, there are some really back-channel things that you can do to kind of get back to a good state or get back to a better state than where they are. So if you ever have to deal with a repository that seems totally messed up, don't blow it away. Find someone who is really good at this and see if they can help you fix it. Anything else? Yes.
Branching is a big deal in Git. Everybody does it all the time. Given the problems in branching in Mercurial, is it used as much in Mercurial repository?
So the way that I see people wanting to do branching in Mercurial is that when you look at Mercurial, they have like some suggested workflows, and one of the workflows they have is that you make a repository, and that is your branch. So I'm guessing what they do is they make a directory, and they say, this is where I'm going to do Jira ticket 235. And then they clone the repository there, and they do their work there. and then when they're ready, they kind of make a patch, and then they apply it to the repository that actually pushes upstream. That's my theory of how they do it, and that's why I think that they don't care. They are not that concerned with branches. I think that named branches is something that people were clamoring for, and this is how it got implemented. Any other questions? I didn't freak you guys out that much, did I? Okay. We're all tired. I guess we could call it the end of the talk. You're all free to go.